Okay, we went through the paper and pencil work to prove this. Interesting problem, but to me it was a lot of work. Certainly typing up's a lot of work for me. I got to an answer, and so what I want to do is just go to Sage and check things out. All right, so let's go to Sage, and we're going to type in the code. So I'm going to type in reset first. Next, I'm going to define the variable n equals. That's a variable now. And I'm going to start to copy paste now. And let's do the next thing. That's defining the function. I'll go over the notes again to show you where this is. And then Boolean. The Boolean return either true or false. All right, it's taking some time to compute. Not sure why. What I'm going to do is go back over this and just go through this. All right. So certainly I'm defining n as a variable. All right. And then I define this this function as sine 2n plus 1 times pi over 180. Right. The reason that this is in degrees, and I have to convert it to radian. All right. And you know, what is it given? 135 up to 99. Oops. Let's go back over this. So let's take a look at that. Well, if I start at 0, this would give me 1 degree, and so forth and so on up to 49, which would give me, let me see, 99. Let's go back over here, and that's 99 over there. So 1 to 99, it's giving me that the terms there. And the sum going from 0 to 49, just summing all the terms together. Let me go back to Sage. It does say it's true. I want to tell you why it might be taking so long to compute. Like if I just tell you what S is a pretty long expression over there. If I want to approximate S though, it's that number over there, all right? And again, let's go back over that. And if you took this thing over here and did that computation, roughly speaking, as a decimal number, it's going to return this over here. How do I know that? I use that Boolean. And the Boolean was comparing that S to that final summation, which is this thing over here. Thank you.